What's going on, everyone? Jay's 2 cents here, and we're going to talk about something that is kind of new but not new. It was a thing for a while and then it came back. We're going to talk about MPRT, or moving picture response time, because we're going to talk about whether or not that's something you should even be considering when buying a new monitor. And with so many more companies now really starting to advertise this as a spec, we're going to teach you about the spec and what it really means.
We interrupt this video to bring you a special message from iFixit. No, we interrupt this interruption with this interruption about new stuff from iFixit. Wish you had a new graphics card, but inventory sucks? Fix the inventory problems with iFixit. Whoa, don't drop it. Can't fix that with iFixit. Just kidding, yes you can. Wish you could take iFixit with you anywhere, but your pockets aren't big enough? Introducing the new More
and the new Minnow.
Take them with you anywhere. So what are you waiting for? Click the link in the description below for discounts and savings and explosions. More explosions. Even more explosions. Why are you still here? Click the description now!
So this educational piece is actually brought to you by ViewSonic. They sponsored us by sending us 2 of their new XG series monitors, which specifically advertise a very aggressive MPRT. So we're gonna be using those today to sort of demonstrate that. But before we get there, before we understand MPRT, we have to kind of know the history of monitors, or why we've even moved towards that spec even being a thing. So let's start with CRTs. CRTs are something that I think most of us grew up with, and it's not really something we see anymore, but it kind of takes us full circle on where we are and why CRT tech is so important even to today. So CRTs, or cathode ray tubes, are monitors that work by firing electron beams at a phosphorescent screen to create images. Now inside the CRT, there's an electron gun that emits electrons. That's why it's called an electron gun. Whoa. And they're accelerated and focused into a beam. Now this beam is directed by a magnetic coil towards specific points on the screen, which is coated in tiny dots of phosphor in red, green, and blue. Now when the electron beams hit the phosphor, it glows, producing light in the corresponding color. And by controlling the intensity of the electron beams and combining these 3 colors, the monitor can display a full range of colors. And this image is built line by line. It's actually very, very cool. Now the refresh rate, or the speed at which this typically happens, is anywhere between 60 to 120 hertz, or how many times per second it's able to actually draw the image. Now that's why when you shoot a CRT TV or monitor with a camera, you get some of the screen not showing up entirely, or you get that flickering image because the camera shutter is open sometimes while the monitor is still drawing the next frame. So that's why you get that sort of a flickering screen. Now CRTs are actually very, very smooth because of the way that they operate. However, they're big, they're bulky, they're heavy, they use a lot of power, there's giant magnets in them. That's why actually bringing a big magnet, like a speaker magnet, near a CRT monitor completely screws up the image, because you're screwing up the entire operation of the way the monitor works. And you can actually permanently damage it by using a magnet near a CRT or putting speakers right next to them. Fun fact, one time I took a big speaker magnet to my dad's 22-inch CRT, which was very expensive in the 90s, and I was like, hoo, playing with the image, and when I pulled it away, it was upside down. So he wasn't too happy about that. Now, obviously, to combat the size and the bulkiness of CRTs, we move on to LCDs, or liquid crystal displays. Now, those have evolved quite a bit over the years. Now, the earliest LCD screens were CCFL LCDs. The LCD refers to the type of display, and then the CCFL refers to the type of backlighting that allows light to move its way through the pixel. Now, CCFL stands for cold cathode fluorescent light. Now, in a CCFL LCD, a series of fluorescent tubes, usually positioned behind or around the edges of the screen, that's referring to either backlight or edge lighting. We'll talk about that in a second. They provide a consistent light source. Now, the liquid crystal layer in front of these lamps controls the amount of light that passes through by twisting and aligning the liquid crystals. These crystals do not produce light, but they do modulate it as it passes through green, blue, and red filters, which is essentially how you get the particular color and the image drawn across the entire array. Now, CCFL backlighting produces a uniform brightness, but consumes more power, and it creates more heat compared to modern LED backlighting, and it also limits the screen's ability to display deep blacks and sharp contrasts, mostly because of the fact that it's just light shining through. So how can you make something really contrast or dark or black? By emitting light. And that's where the pixel gate will shut to stop light, but you always still get some bleed. Now this is where LED LCDs come in. And just like CCFLs, it is a light emitting diode that has an array behind the screen or potentially an edge light, depending on how old the panel is, which has allowed for other techs to start to emerge like local dimming, where specific spots of the screen that are not supposed to be emitting light, they'll actually turn off those LEDs entirely or dim them severely so you get a better contrast ratio without shining light through a closed pixel gate. But besides that, the way they operate are exactly the same as a CCFL LCD screen because the panel tech in front of the light is identical. Now, the monitor refresh rate refers to the number of times per second a display updates the image on the screen. So for example, a 60 Hz refresh rate means that the monitor can refresh the image 60 times per second. And a higher refresh rate like 120 Hz or 144 Hz or 240 Hz or 480 Hz is how many times per second the screen can actually update the image that is being shown. Now that leads us into response time, because the other half of the equation when we talk about how many times per second an image will show on screen. Now response time refers to how quickly a monitor's pixels can change from one color to another, and is typically measured in milliseconds and in a term used G to G, or gray to gray. 1 milliseconds is pretty much the gaming standard today for gaming panels. You'll find some 2 millisecond panels. It's kind of rare these days to find 5 milliseconds panels. In fact, 10 years ago, 5 milliseconds would have been amazing. But now we have IPS technology with 1 millisecond response times, which are great. But we got to talk about the way response time can now be correlated with refresh rate and ghosting, because that's the thing we start to deal with now as we get faster and faster panels, is the fact that the refresh rate of the panel starts to be able to exceed the amount of time that the pixel needs to be able to completely change to a new color. This is where we introduce ghosting. So if a monitor has a high refresh rate but a slow response time, the pixels may not update quick enough, leading to ghosting. Now ghosting occurs when the previous image or part of it lingers on the screen as a faint trail behind fast-moving objects, so making motions look blurry or smeared. And to reduce ghosting, monitors need both high refresh rate and response time, ensuring that quick pixel transitions that match the screen's ability to refresh rapidly. Now we're going to talk about the next evolution of response time, and that is MPRT, or moving picture response time. So we've talked about the measurement of how many times the image can be refreshed per second, that's refresh rate. We've talked about how fast a pixel is able to change color, that is response time. Now we are measuring specifically how long an image remains on screen when in motion. So you take any modern game, esports title or not, and you take the mouse and you flail it around, you're gonna see smearing on the screen. Now, I'm not talking about settings in games where you can turn on motion blur where that's done artificially, where the pixels and the game engine is actually drawing a smudged image. We're talking about the actual physical hardware itself unable to refresh itself fast enough to keep the image from being blurred across the screen. Now, motion blur is kind of natural for most things. You take your hands right now and wave them in front of your eyes, you're not gonna see 5 fingers going by nice and smooth. You're gonna see a fan effect of those fingers being spread out across your vision, because believe it or not, your brain also has a refresh rate and a response time at which it's able to cycle the information coming to it and how quickly it can actually refresh the information. So doing that is very similar to how a monitor would be sort of displaying motion blur because of its inability to either sync pixel refresh rate and response time, where you don't have a pixel still transitioning to a new color or a new brightness before the next scene has actually been drawn on the frame. So now we're going to talk about how the MPRT ratings are achieved and what it actually means. So this is a warning to anyone that's sensitive to flickering images. There is going to be flickering colors and images moving forward. So if you're sensitive to that, you might want to look away, minimize the screen, and just listen. But there is going to be flickering effects on screen. So fair warning right now. MPRT, or moving picture response time, is achieved by 2 different ways. You can either have a black frame insertion, which is where a black frame is actually drawn between each image, which I don't think most people are doing it that way. They're actually doing a strobe effect. So that's where the backlight itself is strobing at a particular rate or Hertz rating. So for instance, with the XG monitors behind me being a 0.5 millisecond MPRT, means that they are strobing at 2,000 times per second. Far faster than your eye would be able to actually see or discern. And I'm not talking about like slow Hertz refresh rate or 60 Hertz of like fluorescent lighting. All lights, these LEDs behind me, anything emitting light right now is not a constant source of, okay, incandescence aside. CCFLs, LEDs, it doesn't matter, anything outside of incandescent, which is just a filament that's glowing due to heat, is refreshing itself. So if you had a fast enough camera, you would see the LED going on and off. So the same thing is happening with the backlight. What this allows is a pixel reset. So the best way to demonstrate this, let's talk about a funhouse effect of like a strobing light. So as you can see right here, I've got the pole in my hand and, sorry, as I'm spinning it around in front of a constant light. Now, as we strobe the light, it demonstrates what happens to motion blur for the camera or even for your eyes. And that's why you go into a funhouse in Halloween with strobe lights, everything looks like a slideshow of flickering images. Even though things are moving, your brain only captures that motion, that one frame for that moment that the light was on. So the same thing happens on the panels, where by cycling or strobing the backlight, the motion blur that would be happening while the pixel is trailing off is cut. So the reason why this is happening is your brain cannot blur an image it cannot see. So in the solid video, as the stick is going around in a circle, you see the fanning effect on the camera because that's how long that frame was able to see that movement. But if you cut that image, your brain can't blur what it can't see. So the same thing is happening on the screen physically. The pixel cannot blur what it cannot see because the backlight itself is dimming to a point to where it's no longer illuminated. So it's the next evolution of response time, again, because MPRT's been around, like I said. So let's do this. Now that we've kind of done an overview of what it means, let's show it as well as we can on camera to sort of give you guys a practical look at what it means and whether or not it's something you should even care about. So this is where we get into the sponsored bit of the video, but I am thankful for ViewSonic to send us these panels because I don't have any panels right now on hand that actually advertise these MPRT ratings or even achieve it through strobing. So what we have on the left right here, this is the XG2736 2K, so it's a 1440p, 240 hertz monitor, IPS, specifically designed, both of these are specifically designed for esports gaming or people who demand the least amount of motion blur possible. Motion blur is such a controversial topic. I personally like motion blur because I'm not a competitive gamer. I like the cinematic look of, yeah, I know I'm digging myself a hole right now. I'm just gonna keep on digging. I personally think I like a little bit of motion blur because it sort of masks any of the refresh rate changes or any of the frame rate changes that happen as you move around a scene. And to me, it looks more natural. But if you are trying to get the most amount of updated information when it comes to like any sort of shooter or Twitch response type game, whether you're an esports gamer or just a competitive person in your bedroom, then these are the types of monitors that are going to, yeah, there was probably a joke in there, but these are the kind of monitors that are gonna absolutely appeal to you because of the 0.5 millisecond MPRT. It's got 1 millisecond response time mode. It's 2 milliseconds if you don't turn it off on the 27 inch, if you don't turn on 1 millisecond mode. Otherwise, then it goes to 1 millisecond. Fun fact too, if you don't turn on 1 millisecond mode, you don't get the strobe, but you get VRR. So I'll talk about that in a second. And it's got the 240 hertz refresh rate. Now, over here, the XG2536 is a 1080p panel, but it's 240 hertz overclockable to 280 hertz. And it happens by default, basically. So if you turn on 1 millisecond mode, I got 280 hertz that showed up in Windows. It's doing the same thing as the 27 inch. It's just 25 inch is apparently the preferred esports size because I can't do this. Phil will tell you, I'm farsighted. Apparently, this is how you have to esports game. In my esportsing, right? You gotta be like that guy in the golf course that has like the shiny new Mizunos or I don't know, some really custom tailor-made, and you get up there and you just shank the shit out of your first drive in front of everybody. So anyway, I'm gonna move this back to a reasonable distance because again, I'm farsighted. I couldn't see crap with it that close to my face. I'd be screwed. So apparently 25 inch is like the esports size because of distance to eye movement ratio or some crap. You know, look, these guys are out there making big bucks playing games. Who am I to judge, right? So my gamer position is leaning back in my chair with my feet up. I can't play any other way. So anyway, let's go and talk about some of the settings and such. So I talked about 1 millisecond mode and variable refresh rate. So there's a trade-off that happens here. You have to prioritize either variable refresh rate, so that would be maybe if you had a graphics card that was a bit too slow for the refresh rate of the panel, which is 240 for both of these or 280 for the 1080p, or the super fast MPRT response time. Because as soon as you turn on 1 millisecond mode, which activates the strobing, you lose VRR. And that's because of the fact that the strobing and the frame rate has to be as locked as possible to make that consistent. We have a response time, we get standard, advanced, and ultra fast. Now, part of the problem here, if you go to ultra fast or you start to really overdrive the panel, is you start to get what's called doubling, or you get a forward ghosting. So essentially what overdrive is doing is it's actually increasing the voltage to the pixels to try and make them turn faster. I talked about the limitation of how fast physically the pixels can move. So when you enable an overdrive, it's essentially like overclocking the pixel, not the refresh rate of the panel. People have heard of overclocking with panels. That would be like 240 to 280. That'd be an overclock because we're changing the cycle of the panel. But we're changing with overdrive the voltage going to the pixel. And what can happen is you can make it overshoot. And when it overshoots, that's where you get the image drawn in front of the moving object. And you can get some other artifacts and over sharpening and other things that can happen. So with overdrive on this panel set to ultra, we were getting a little bit of overdriving of our UFO where you'd see some of it in front of it. We'll show that on screen because it's really hard to show live like this. So we find that advanced tends to be about the best middle ground. Let's talk about the inputs real quick. You have 2 HDMIs and a display port. The HDMIs are obviously for if you're doing console gaming. But what I want to point out, on the 1440p panel, the HDMI limits you to 144 Hertz, not the 240. So use a display port when hooked up to a PC when possible, because that's the only way you're going to get your 240 Hertz, and it's also the only way you're going to get your MPRT of 0.5 milliseconds. The other panel over here, the 1080p panel, is all identical with the exception of the fact that you do get overclocking, which is right here. So this is where it's on to create 280 Hertz or off for 240 Hertz. Okay, so we're at 1440p. I also need to make sure that any motion blur is off because right here, see motion blur is set to low. That's fake motion blur. That's the game creating the smudginess. We don't want that. And this is for people that obviously would absolutely hate that. I'm okay with it, as you saw. We have a 4090 hooked up to it. That's something else that's very important. To get the MPRT to be extremely consistent, you need a fast, powerful graphics card to be able to push the frames to at least the base frame rate of what the monitor is capable of. So in this case, we need 240 FPS. And not only that, if you're running a high-end graphics card, you're gonna need a fast CPU as well to be able to keep up with those frames. So this is one of the reasons I personally like a little bit of motion blur, not by the panel ghosting, but by the game introducing it. Because as we move it around fast, what we're seeing here, we're seeing the individual frames that we're drawn as we're moving it across the screen. So the motion blur, like in a game, sort of hides that. But there's information in here. So for someone that's esports gaming and they're like responding to things happening on the screen, if your refresh rate is too slow, then information is happening between when you're seeing it. So that's why these high refresh rate and MPRT screens are important, because now if you're drawing the frame but it's blurred because of ghosting, you're still losing some information that's being camouflaged in the blur. So it's about response time for your eyes and your reaction time in esports gaming than it is about the monitor just creating a crisp image. It's creating a crisp image that you can process without waiting for that image to unsmudge itself. We're gonna go to 1 millisecond mode and turn that off. Now we got more brightness too. Something else I want to point out. Now the reason why the backlight dimmed a little bit with it on and came back brighter with it off is because it's no longer strobing. So there is time that the screen is off, which is going to reduce its overall perceived brightness. Now these are 300 nit panels, and that's one of the reasons why they're not so bright either, is because of the fact that they are, so it's a trade-off. You're going to find some panels out here that are advertising 400 nits with like a 1 millisecond MPRT. These being a 0.5 MPRT, it means that the screen is actually off more than the 1 millisecond MPRT screens. So again, 1,000 times per second cycling versus 2,000 times per second. So that's why it looks perceived dimmer, because it actually is, because the amount of time that it's off. Oh yeah, it's weird. Like it may not pick up on camera great, but it has like almost like a dizzying effect. It's one of those things that like you don't necessarily notice it until you immediately get an A/B test on this. Let's talk about now MPRT and whether or not you should care. It really is something that is going to be interesting to those that are absolutely, positively in I despise motion blur type of mentality. That's clearly not me. If I'm enabling motion blur at least low in games, you can tell I'm fine probably if the monitor itself is not trying to cut it out. Now there is a difference between motion blur due to the hardware of the monitor being too slow versus fake motion blur, which is just taking an image and adding like a blur effect to it when there's motion, which is going to look more realistic than hardware blurring. This is also why you would definitely want to turn off motion blur in the game if you're turning on the fast response time in the panel, because then it's going to try and crispen the blur, which is going to look even weirder. So fortunately, this is not tech that is driving prices up. Tech that has driven prices up in the past, high refresh rate panels. The first 120 hertz panels were very expensive. And then they got cheaper as time went on because they were just dealing with like TN panels, which are terrible when it comes to viewing angles and color accuracy, but they were fast. Then the first IPS panels came out, and they were very expensive because they were considered more of a business tool. People that needed them in creativity spaces like photo editing and video editing because they needed accurate colors. But the technology lagged where they were stuck at 60 FPS with slow response times for many years, mostly because the people that were using them in more static type environments. Then the tech advanced to where you could get IPS panels at 1080p, 1440p, 4K at fast refresh rates and fast response times, which drove the prices up. Now that's like the industry standard where prices have come down. Then OLED. OLED's a very expensive technology. The price to produce OLED panels is extremely expensive. Fortunately, it doesn't really cost them a lot to strobe the backlight. As long as the panel manufacturer that they can get the panel from can get consistency, because it has to be very consistent at the frame rate, at the rate, at least the hertz rating that it is strobing, in this instance, 2,000 times per second. That's all you have to be able to do. And LEDs are capable of that, fortunately. Especially with full array backlighting now, which means there's LEDs behind the entire backlight, not edge lighting it and then reflecting it off foil back at you. So it's cheap. It's not expensive to do this. And that's why we're able to see these monitors with these extremely fast response times be reasonable in price. Now, the prices of these are usually in the upper 200s to mid to upper $300, depending on the size of the panel. So I'll put links to these panels down below. And again, a huge thanks to ViewSonic for sending these to us to be able to make this video to try and educate about what MPRT is. And fortunately, it's not one of those boxes that you check that immediately like doubles the price of a panel. Now keep in mind, there are a lot of brands out there that are advertising extremely fast MPRT, but there's no standard in the way that it's measured. But there's a lot of panels out there that are just being a little bit disingenuous in the way that they're advertising and showing that they're getting these particular ratings. So be mindful of that if you're shopping brands that you've never heard of that are advertising these rates, because you don't know exactly how they're doing it or the quality at which they're doing it. So fortunately, the prices of these panels is not astronomically ridiculous to where you're like, oh, you know, it's costing me twice the price that I would pay for it without the feature tech or the feature set, just because of the fact that it's got the feature set. It's an easy thing to implement. And I think more panels as we move forward in the future are gonna definitely be utilizing this type of tech. So this is where you guys sound off down below. Trust me, I have heard so many times in my live streams where I game or anything where I demonstrate, I've talked about the fact that I'm okay with motion blur. I'm gonna assume by the amount of you that literally wanted me to be lynched for liking motion blur, you all should be out here buying one of these right now, because if you hate it that much, you gotta put your money where your hate is.